Millikan Experiment Research Project by Callan and Travis. Who was he? Robert Andrew Millikan was born on March 22, 1868. He was an American experimental physicist honored with a Nobel Prize for Physics in 1923 for the measurement of the elementary electronic charge and for his work on the photoelectric effect. Robert Millikan graduated from Oberlin College in 1891 and got his doctorate at Columbia University. Experiment details. The oil drop experiment was performed by Robert A. Millikan with the assistance of Harvey Fletcher. Definitions. Coulomb. The Coulomb, unit C, is the International System of Units, SI, unit of electric. Newton/Coulomb. Sometimes scientists describe electric field in newtons per coulomb. Electric field, a region around a charged particle or an object within which a force would be exerted on the other charged particles or objects. Robert A. Millikan and Harvey Fletcher started the experiment in 1908 at the University of Chicago, and Millikan published his seminal study in 1913. Equipment. Millikan and Fletcher's apparatus incorporated a parallel pair of horizontal metal plates by applying a potential difference across the plates. A uniform electric field was created in the space between them. A ring insulating materials was to hold the plates apart. There you can see some diagrams on it. Here's a link to a good simulator that may be useful. Some more experiment details. Millikan and Fletcher started experimenting in 1908 while he was a professor at the University of Chicago. Millikan used this experiment to determine the charge of the electron. Millikan sprayed oil droplets through the hole on the upper plate. Then he let the droplets reach terminal velocity. He measured the terminal velocity using a microscope and a formula. Millikan was pretty close to the answer despite manipulation of the data. His result was 1% close to the actual value. Next, Millikan applied a charge to the falling drops by illuminating the bottom chamber with X-rays. This caused the air to become ionized and electrons to attach themselves to the oil drops. By attaching a battery to the plates above and below this bottom chamber, he was able to apply an electric voltage. The electric field produced in the bottom of the chamber by the voltage would act on the charged oil drops if the voltage was just right. The electromagnetic force would just balance the force of gravity on a drop, and the drop would hang suspended in midair. Some controversy regarding the experiment. When people went over Millikan's records, they got an unwelcome surprise. It seemed that a few drops had been omitted. In fact, 115 drops had been omitted. In Millikan's notes, certain specific drops were omitted and considered obvious errors because they veered away from Millikan's expected value for charge of the electron and towards the value that Millikan's scientific rival, Felix Henraft, predicted for the electron. Millikan's experiment has come into disrepute. While no one can dispute that Millikan's predictions were accurate and that experiment works, the concealed conflicting data has turned the oil drop experiment into a famous case of misconduct. Some people even call it fraud. And there it is. So here's an example question. I'll set the channel lights. Find the solution to an oil droplet is suspended in midair above the charge plate. The field strength, the elementary charges. The field strength at the point where the droplet is 75 newtons per coulomb. The charge on the droplet is estimated to be 3 elementary charges. What is the mass of the oil droplet? Well, here we are. The first step you have to do is you have to find your charge in the Elch formula. So there it is there. Second step is you have to find the FW to find the formula for mass, as you can see right there. And there you go. You use the FW formula, mg, and there you are.